Good morning, students. Next, we are going to see non-sinusoidal oscillators. One of the practical example for non-sinusoidal oscillator is multivibrators. So today we are going to see the multivibrators concepts and what are the types of multivibrator that we will discuss now. So multivibrator is a circuit. It's a two-stage switching device, switching amplifier. Is a cross-coupled switching amplifier. So we have two CE switching devices, and the output of the first one will give it to the input of the second one, and the output of the second one will be given to the input of the first one. So it's a cross-coupled switching device. So here we are going to utilize the switching characteristic of BJT because as we know earlier, as we studied earlier, the major applications of bipolar junction transistor BJT is two applications. One is the amplification, second one is the switching applications. There are three different working regions in BJT. One is the active region, second one is a saturation region, third one is a cutoff region. So depending upon where the BJT is placing the region, the application will be different. If the BJT acts as an amplifier, we utilize the BJT in amplification application, that should be placed in active region. When we make that BJT in switching application, that should be placed alternatively saturation region and cutoff region. When the BJT placed in saturation region, it acts as a closed switch. When it is placed in cutoff region, it acts as an open switch. So alternatively, the BJT will change the state between saturation and cutoff. It acts as an on-off switches. So that is a basic logic of this multivibrator circuit. Based on this, we can able to produce a continuous square waveform or train of pulses or rectangular waveform. Based on the duty cycle, the on period and off period will differ. So that is one of the application of multivibrator. So using this multivibrator, we can able to generate a continuous square waveform, continuous train of pulses. We can able to generate a single pulse with a defined width, and it acts as a binary storage device. These are the major applications of multivibrators. So let's see what are the types of multivibrators. So based on the states, stable and quasi-stable state, the multivibrators is broadly classified into three types. The first one, astable multivibrator, and the second one, monostable multivibrator, and the last one, bistable multivibrator. The astable multivibrator, the major differentiation among these three is how many stable state and quasi-stable, unstable state it has. So based on that, there is a first point, each one will differ. And second one, how many external trigger pulse is required for its operation. Based on that, it will differ. So let's start from the first one, astable multivibrator. It has no stable state. Both the states of astable multivibrators are quasi-stable. And second one, monostable multivibrator. It has one stable state and one quasi-stable. There are two two states in the multivibrator. One is a stable, other one is a quasi-stable, and last one bistable. Here both the states are stable. There is no quasi-stable in bistable multivibrator. So that is a first point of difference among these three multivibrator circuits. And second one, whether it requires external trigger pulse or not. When we start with a stable multivibrator, it does not require any external trigger pulse. It does not require external trigger pulse. And second one, monostable, it requires one external trigger pulse. And last one, bistable, it requires two trigger pulse. Two external trigger pulse. That is the second difference among these three different types of multivibrator. And the third one, what are the other name, or what type of waveform it's going to generate? The astable multivibrator is used to generate a continuous square waveform. And second one, monostable, it's going to generate a single pulse at a time. We cannot generate the continuous pulse chain using monostable. We can able to generate a single pulse at a time. And the last one, bistable, it acts as a binary storage device. Since both the states are stable, 1 and 0, so it's going to act as a storage element, binary storage element. That is the third one. And what is the other name of this astable is a free running multivibrator. Free running multivibrator. Since it does not require any external pulse, as soon as the supply is given, it starts generating the waveform. So it is called as free running multivibrator. And the monostable multivibrator, the other name is, it's a one-shot vibrator. One-shot multivibrator. And the last one, bistable, is a flip-flop circuit. These are the other names of all three kind of multivibrator. So the next class we will see the working of astable and monostable and bistable multivibrator. Thank you. Good morning. Next we will discuss the working of multivibrators. So let's start from astable multivibrator. So as I said earlier, we have two stages of cross-coupled amplifier circuit, common emitter. So the output of the first one, here we have a two stage Q1 and Q2. The output of the first stage will become an input of the second through the coupling capacitor or through the capacitor C1. And the output of the second one will be coupled to the input of the first one through the another capacitor C2. And here R1 and R2 is a biasing resistor, and RC1 and RC2. These are all the collector resistor, R1 and R2. The output will be taken from the collector of both the transistor. Any of the transistor we can take. This is the VC1 you can take. This one is VC2. Here the emitter is grounded. So in a stable multivibrator, there is no stable state. Both the states are unstable. There is a quasi-stable state. So it does not require any external trigger pulse. Now there is no trigger pulse in this circuit. So here the supply is given PCC. So now let's see the working of this. How this circuit generates the continuous square waveform. When the supply is given, due to some imbalance of the circuit, any one of the transistor will be driven into saturation, the other one will be driven into cutoff. But we don't know which transistor is going to be enter into saturation and cutoff. Let us assume your Q1 is in saturation, that means on, and Q2 is off. Before coming to this working, we must know the voltage level of on and off of transistor. If you take any transistor, if it is on, it must be placed in saturation region. So that base voltage is equal to VBE saturation. That base voltage is equal to VBE saturation when the transistor is in on state. That VBE saturation is nothing but 0.7 volt. Same thing, your collector voltage will be equal to VCE saturation. That value will become equal to 0.2 volt. These two are the voltage level at base and collector when the transistor is in saturation or on state. When the transistor is in off, that is a cutoff state, the base voltage VBE is equal to negative. If the supply is plus 5 volt, your VBE in cutoff is minus 5 volt. That is the negative of your supply, maximum voltage. Same thing, your collector voltage VCE, which is equal to the supply voltage, that is VCC. These are all the voltage level at base and collector of the transistor when it is in on state and off state. Now we continue the working of A-stable multivibrator when the supply is given. So when the supply is given, any one of the transistor will be driven into on state. So let us consider Q1 is on and Q2 is off. Once the Q1 is on, the corresponding transistor, actually you take this is a Q1 and Q2 here. This is on, the corresponding capacitor, the capacitor associated with this Q1 start charging. The voltage across the capacitor will be given to the base of second one. So when it reaches 0.7, that driven Q2 to on state. So it goes to on. Once it goes to on, the corresponding collector voltage is VC saturation, which is 0.2. It is given back to the base of Q1, which is less than 0.7. Then the Q1 goes to off state. So it goes to off. So now the Q2 is on. So now your Q2 starts conducting. The capacitor associated with this Q2 starts charging. That voltage will be given to the base of Q1. Once it reaches 0.7, that makes that Q1 to on again. So alternatively, this Q1, Q2 on and off will produce a continuous square waveform. So now we are going to see the frequency of oscillation of A-stable. Let T1 and T2 is the on and off period of any one transistor. So Q1 is equal to 0.693 R1C1 and T2 is 0.693 R2C2. So the total time period is T1 plus T2. Then the frequency of oscillation is 1 by T. If the circuit is symmetrical, assumed to be symmetrical, R1, R2 equal to R, C1, C2 equal to C. So therefore, T equal to 1.38 RC. So frequency of oscillation is 1 by T. That is the working of A-stable multivibrator. So in this one, we supposed to know the waveforms of collector and base node. We supposed to know how to draw the waveform for this one. So based on the discussion, your Q1 is initial state. Actually, we are supposed to draw the waveform of collector and base of both the transistor. So VC2 and VB2. So there are initial stage, we assume Q1 is on. So if the Q1 is on, your collector voltage is VC saturation and base voltage is VB saturation. And Q2 is off, your collector voltage is VCC, base voltage is negative. Now the capacitor start charging. Once it reaches 0.7, your Q2 is on. That is the second one. First state is Q1 is on and Q2 is off. And the second one, Q1 is off and Q2 is on. So the collector voltages goes to VCC and your base voltage coming to the negative. And here the second transistor collector is VC saturation and second one base is VB saturation. The same thing repeat again and again. So that will produce a continuous square waveform at the collector of both the transistors. That is a entire working of astable mode multivibrator. Thank you. Good morning. We are going to see the second type of multivibrator. It's a monostable multivibrator. As we discussed earlier, there are three different types of multivibrators in market. One is an astable multivibrator that we have discussed already. So it's no stable state. Both the states are quasi. The second one is a monostable multivibrator. From the name itself, we can define it has one stable state and one quasi-stable state. And second important difference between among this three types of multivibrators, second one is types of coupling. What types of coupling we are going to use? In astable multivibrator, we used capacitive coupling. Here we use resistive capacitive coupling. And third, how many external trigger pulses required for its operation? Since the astable multivibrator does not require any external trigger pulse, it is called as a free running multivibrator. But in monostable, it requires one external trigger pulse. External trigger pulse for its operation. So these are all the important points related to monostable multivibrator. Let's see how the monostable vibrators is going to generate the waveform. Actually, the multivibrator is a cross-coupled switching amplifiers. Here also we have two transistors. Here we have RC1 and RC2, which is connected to the supply VCC, and the output of this one is, you take it as Q1 and this one is Q2. The output of Q1 is connected to the input of base of Q2 through the one of the coupling device capacitor. At the same time, the output of the Q2 will be connected to the input of Q1 through the coupling device's resistor. That's why here we use resistive and capacitive coupling. C1, R1. And we have two resistors here. One is in R2. That's all. And the output will be taken from the collector of Q1 or the collector of Q2. Now, when the supply, again, and one more thing, it requires one external trigger pulse. So, the base of Q1 should be connected to the minus VBB. It's a negative supply through the base resistor RB. From the base of Q1, we will connect, or we are going to apply the external trigger pulse to the base of Q1. So here we have external trigger pulse for the state change. When the supply is given in astable multivibrator, the initial state of both the transistors we don't know. So due to the imbalance of the circuit, any one will be driven into saturation and any one will be driven into cutoff. But here we know the state. As soon as the supply is given, one transistor, which we can say Q1 or Q2, whatever it is, we can say one is in on, other one is in off. That state we call it as a stable state. When the trigger pulse is given, the state change will happen. So the entire circuit will go to one state. That state is a quasi-stable. So the entire circuit will remain the state for some time period. After the time period, the entire circuit will come back to its original stable state. Now, since the base of Q1 is connected to minus VBB, initially when the supply is given, the initial state of the entire circuit is Q1 is off and Q2 is on. So when now we are going to trigger, or we are going to make that Q1 to on by applying the external trigger pulse to the base of Q1 through this line. When this voltage overcomes minus VBB, because that minus VBB is a negative voltage, negative supply voltage to the base of Q1 that provides reverse bias to the base emitter junction. For example, let's take that VBB is 3 volt, minus 3 volt. That is a reverse voltage, reverse bias voltage between base to the collector of Q1. So, if you want to make this Q1 to on, we should apply the trigger pulse. That magnitude should be greater than this 3 volt. So, when you apply the trigger pulse with the voltage level is 4, that makes that base emitter junction of Q1 is forward. That makes that Q1 to on. Initially, the Q1 is off. When the external trigger pulse is given with a sufficient magnitude level, that makes that Q1 to on state. Once it enter into on state, its collector voltage is VCE saturation. That is 0.2 volt, which is directly coupled to the base of Q2, which is less than 0.7. That makes that Q2 to off. This state is quasi-stable state, not a permanent state or stable state. The entire circuit will remain the state for some time period. Now, the Q1 is on, so it starts conducting. The capacitor associated with this Q1 starts charging. When this voltage, capacitor voltage reaches 0.7, which will be the base voltage of Q2. So, when it reaches 0.7, that is the cut-in voltage of the BJT that makes that Q2 to on again. Once it goes to on, your collector voltage is equal to VCE saturation, that which is directly coupled to the base of Q1 through the coupling element R1, which is less than 0.7. That makes that Q1 to off again. So once it comes to the off, again the entire circuit will remain the same state until the next trigger pulse is given. So this state is stable. Your Q1 is off and Q2 is on. That state is stable state. Whenever you apply the trigger pulse, the state change will happen. Your Q1 is on and Q2 is off. I am talking about the circuit. Based on this circuit, I am giving this state. So once the trigger pulse is given, your Q1 is on and Q2 is off. This one is a quasi-stable. Again, some time period, it will come back to its original stable state, off and Q2 is on. So the circuit will remain the same state until the next trigger pulse is given. So at a time when the circuit starts operating, it can able to generate a single pulse at a time, not a continuous square waveform like astable mode. Whenever we apply the trigger pulse, it generates the pulse. So we can able to control the pulse width of the monostable multivibrator by using the time constant RC. So the time constant or pulse width, the time constant T, which is equal to the time period T of this pulse width. This one is T. If you take this as a T, the T is equal to 0.693 R2C1. That is the entire working of monostable multivibrator. Thank you. Good morning, students. The last type of multivibrator is a bistable multivibrator. The points, important hints related to this bistable multivibrator is, start with the status. Here the bistable, both the states are stable state. It doesn't have any quasi-stable. And second one, here we use resistive coupling. In astable, capacitive coupling, monostable, RC coupling. But in bistable, both the coupling elements are resistor. Here we use resistive coupling. Last one, how many trigger pulses required? Here in bistable multivibrator, it requires 2 external trigger pulse. One is set, other one is reset. So these three are the points related to bistable. Let's see the working of bistable multivibrator. As I said earlier, like monostable and astable, here also it's a two-stage switching amplifier. So it has two transistors Q1 and Q2, and here RC1 is a collector resistor of Q1 and RC2 is a collector resistor of Q2. The output of the Q1 is coupled to the input of Q1 through the coupling element resistor R1. Same way, the output from Q2 that will be connected to the input of Q1 through the coupling element R2. Here the supply is VCC. So in order to increase or speed up the transition on and off state change, we are going to connect two capacitors which is parallel with the two coupling element R1 and R2. That you take C1 and here we put another capacitor C2. So this C1 and C2 called as a commutating capacitor. Commutating capacitor or speed up capacitor. The purpose of these two capacitors are to speed up the transition between on and off state. And again, as I said earlier, it requires two trigger pulses. So both the bases are connected to the negative supply minus VBB through the resistor R3 and R4. From the base of Q1, we apply one trigger pulse, trigger 1. And from the base of Q2, we apply the second external trigger pulse, trigger 2. One you take it as a set, other one you take it as reset. There are two external trigger pulse for its operation, bistable multivibrator. Right. Now we are coming to the working. When the supply is given due to some imbalance of the circuit, like astable. The initial state we can't say here, we can't predict. Say any one of the transistor will be driven into, because both the bases are connected to minus VBB. But in monostable, one transistor base is connected to minus VBB. That's why we could say the stable state when it starts working. But here, both the base is connected to minus VBB. Again, its initial operation is similar to astable mode. When the supply is given, due to some imbalance, any one of the transistor will be driven into saturation, the other one will be driven into cutoff. Here, let us assume your Q1 is on and Q2 is off. Now the Q1 starts conducting. When it is on, corresponding VC equal to VC saturation and VB equal to VB saturation. The voltage level of off state of the BJT is your collector voltage is equal to VCC and base is negative. Here there is no capacitor as a coupling device. So both the coupling elements are resistor R1 and R2. Now here when as soon as the supply is given, the initial state we assumed is Q1 is on and Q2 is off. Now we are going to make your Q2 to on. So in order to switch on the Q2 to on, we apply the external trigger pulse at reset pin or at reset point, trigger 2. When this magnitude, reset external trigger pulse magnitude overcomes minus VBB, that provide a sufficient forward bias to base emitter junction of Q2. That makes the Q2 to on. Once it goes to on, its collector voltage is VC saturation is 0.2 volt, which is directly coupled to the base of Q1, which is less than 0.7. That makes the Q12 off. This state is also stable state. Now we are going to switch on the Q1 from off to on. In order to make the transition, we apply the external trigger pulse, external positive going trigger pulse at the set trigger 1 point, set point. So when it overcomes that minus VBB, that makes that Q12 on again. Once it goes to on, its collector voltage is VC saturation is a 0.2 volt. That makes that Q22 off. Whatever the state changes may be, the entire circuit will remain in that state, new state, until the next trigger pulse is given. Whether it may at set 1, that is set, or it may at reset, trigger 1 or trigger 2. So whenever we apply the trigger pulse, the state change will happen. So that's why this circuit is known as flip-flop circuit, binary circuit for storing 1 and 0. That is the entire working of bistable multivibrator. Next we will see the output waveforms, that is the collector waveforms of this bistable multivibrator. So in that waveform, we are going to draw the waveform at the both the output, that is VC1 and VC2 with the trigger pulse set 1 and set 2. So here, the first one we take it as VC1, collector voltage of first Q1, and second waveform we take it as VC2, collector voltage of second, and third one is a set trigger pulse, and fourth one is a reset trigger pulse. Reset trigger pulse. The initial state of your bistable is due to some imbalance. We have assumed the Q1 is on and Q2 is off. Q1 is on and Q2 is off. That is the assumption only. So when the Q1 is on, the corresponding collector voltage is VC saturation. But this VC2, Q2 is off, it output to VC is a VC saturation. Now we are going to apply the trigger pulse at positive going trigger pulse at Q2, that is a reset. There we have taken that one is reset. So we are going to apply the trigger pulse at reset. When you apply the reset, this second transistor is driven into saturation. First one is going to off. Next phase of working, we are going to apply the trigger pulse at set point, that is a trigger 1. So here, set. When it's set, again your Q2 goes to off and Q1 goes to on. So this one is set and this one is reset. That is a entire waveform of bistable multivibrator. So far we have completed all three types of multivibrator: monostable, bistable, and astable. So now we consolidate all three all three points, whatever the points we discussed. So I give the comparison table of all three multivibrator. So what are the parameters we are going to compare? The first one is state. How many stable state, how many quasi-stable state. That's the first difference when you form the comparison table among these three multivibrator. And second one, coupling element. What are the types of coupling element we are using? And third one, trigger pulse. How many trigger pulse is required for its operation? Trigger external, trigger pulse. The last one, how it is known, what are the other name of that multivibrator. So the first one, astable. Astable, for remembrance only I am giving this because we already discussed this one. Astable, state is both the states are quasi-stable. There is no stable state. Coupling element, capacity coupling. And trigger pulse, no trigger pulse. It does not require any trigger pulse. So that's why it is known as a free running multivibrator. Free running multivibrator. Second one, monostable. In that monostable, one stable and one quasi-stable. And here we use RC coupling, resistive and capacitive coupling, and it requires one trigger pulse, one external trigger pulse. and it is called as a one-shot vibrator. One-shot vibrator. And the last one, bistable. Both the states are stable state, two stable state. First one, and second, here we use resistive coupling, R1 and R2. In addition to resistor, in bistable we use two more capacitors, C1 and C2, which is connected parallel with R1 and R2. That name of that capacitor is a speed up capacitor or commutating capacitor. It is going to speed up the transition between on and off, saturation to cutoff of both the transistors. So that is the purpose of using additional capacitor in bistable multivibrator. And the third one, trigger, it requires two trigger pulse. And thus it is otherwise called as a flip-flop circuit or binary circuit. So that is the entire comparison table of all three kind of multivibrators. Thank you.